Hello and welcome to today's European SharePoint Office 365 and Azure Community webinar. My name is Orla and I'm delighted to be joined by Marc Duiker from Ably in the Netherlands, who will talk to you today about how you can start building serverless applications on Azure. Remember to join in the conversation about today's webinar on Twitter. Our Twitter handle is @EuropeanSP and our hashtag is ESPC22. Don't forget to check out the Resource Centre. This is updated daily with the latest blogs, ebooks, webinars, and how-to videos. Simply visit sharepointeurope.com and click the content link at the top. Continue your learning by joining us again on the 31st of August for a webinar called Tips, Tricks, and Game Changers for Citizen Developers in Power Automate and Canvas Power Apps with Rory Neary from CPS in the UK. Find out more at sharepointeurope.com/register for webinars. Deep dive into topics of your choice with the ESPC22 tutorials. Experience a full-day expert-led workshop on the SharePoint framework, search, security, AI, hybrid work, Azure Arc, Microsoft 365, or Microsoft Viva. Find out more at sharepointeurope.com/ESPC22-tutorials. Our ESPC 22 early bird sale is now on. Save €200 on 3- and 4-day tickets. Find out more at sharepointeurope.com. After the webinar, we will have a questions and answers session. Type any question you have in the questions window. Questions will be selected and answered throughout and at the end of the presentation. This webinar will be recorded and added to the Resource Centre, where you'll be notified by email when it's available. And now I'm going to pass you over to our presenter, Marc. Hello, Marc.
Hi there. Glad to be here.
Good to have you.
Share my screen very soon. Just a second. And here we go.
Yeah, we can see it now. Thanks, Marc.
Perfect. All right. Welcome everyone. Thanks for joining this webinar. I'm going to talk about how to start building serverless applications on Azure, and we're going to focus on Azure Functions. So I'm Marc Duiker. I'm a senior developer advocate for Ably, and at Ably we enable developers to build live and collaborative experiences. So if you're looking for like a WebSocket as a service, then we're the place to be. I'm also very passionate about drawing pixel art. So this is a drawing I made for me and my colleagues, and I also like to create some kind of retro games now and then. I've been a Microsoft MVP for the last 4 years. I'm also a co-organizer of Serverless Days Amsterdam. So if you're interested in serverless and you're in the Amsterdam area, then please reach out because we're always looking for speakers. But today we're going to talk about building serverless apps. And first I'm going to give you a bit of the theory, not too much, just a couple of slides about serverless in general, then a bit about Azure Functions, and then it's going to be a hands-on experience. So I'm going to actually build an HTTP trigger Azure function, modify it a bit, and then I will deploy it to Azure, and you can tag along with me and create it. So let's first talk a bit about serverless in general. So let's say it's still a relatively new technology, right? I mean, it's been out there since maybe 2016, 2017, and is still quite growing in popularity. And one of the most popular things about serverless is what is more well known as functions as a service. So it's a compute component, right? So it's a piece of logic that is executed when it's invoked. And so as a service means you don't have to manage it much. So you run it in the cloud, and most of it is managed for you. So you don't have to worry about infrastructure and setting things up, which is really nice. It's very easy to get started with it as well. But it's not only scoped to functions. It's not only scoped for compute. So these days are also like databases, which have a serverless model, and also analytics or AI services as a service. And maybe a bit more on that later. But today I'll be really focusing on functions as a service, and then more specifically Azure Functions. So the benefits of serverless are really like you can focus on just writing the code and the code that you really need to write for your business domain. So you don't have to worry about installing or configuring servers or things like that. So it is really nice, and it really allows you to write just the things you need. serverless, and specifically the functions, are event driven, and so they are reacting on something. And so when you call a URL, that means you can trigger a function, or when you put a message on a queue, you can trigger a function, or where you write a blob file to blob storage, you can trigger a function. So everything is event driven, and that's also what makes it very scalable. The nice thing about serverless is that it's completely auto scale, so you don't have to worry about if the load becomes higher, how do I make sure that I can handle the load? No, that is taken care of you. Also, when there are no visits at all, so you need to scale back completely, so you don't need any servers. So also that's possible with serverless. So in that case, when there's like no workload, you're also not paying for anything, which is great. So the payment model, the pay as you go, is really nice, especially if you just started out. You pay first nothing, because usually you have a kind of a free tier, so you can do like 1 million executions a month, function executions a month, and you don't pay anything for that. But if you go above that threshold, you usually pay just a couple of cents for more execution. So it's really cheap to get started with. So I mentioned the workload a couple of times now. So serverless is not always the best solution. So if your workload looks like this on the left, so it's a spiky workload. So maybe, for instance, you do deliveries for lunch and dinner. Well, then you will have a spiky workload when it's lunchtime or when it's dinner time. So in that sense, it makes sense to use serverless, right? Because normally the baseline is very low, so you don't need a lot of servers and don't need a lot of compute, but at certain times you do need a lot of compute, and then you need to scale out, and that's what serverless does for you. If you have a high constant workload, then serverless is probably not the best for you, so you actually might be paying more than choosing for something else, like for instance an app service where you pay a fixed fee a month. But if you have either a low constant workload or a spiky workload, then serverless is excellent for you. So these days, software architecture looks a bit different than before, right? Because we used to have these big monolithic applications. We have just one very big application server and one very big database server. But these days, it's very much componentized and very modular. So when we look at the serverless architecture on Azure, we see lots of small function apps, usually decoupled with queues or service buses, and they communicate with other function apps, and eventually there's also some storage involved. And that could be traditional SQL storage, but it could also be like table storage or anything else. So instead of having one very big application server and one very big database server, you'll have lots and lots of tiny function apps, and then also lots of queues and lots of different storages. So the nice thing of this is when something breaks down in here, and stuff in the cloud always breaks down, right? So that will happen. But if one tiny part breaks down, it means that the other parts are still running and still functional. So in total, your serverless architecture should be more resilient than if you just rely on one big thing. Because if that one big thing fails, then you usually have more issues than when you have a serverless architecture. Of course, this also means that you have to be really careful about your operations and your continuous integration and continuous deployment, right? Because when you have a lot of function apps, you should be really reliant on automating this CI/CD process, so you're not deploying things manually. So we will deploy a function manually, but when you're really running in production, then you should really rely on a lot of automation and make sure that things are deployed to the cloud automatically, because you will deal with a lot of individual small function apps and queues and databases. All right, so let's move on to Azure Functions in specific. So functions in Azure, they have a certain structure. So your function consists of a piece of code, and that code is triggered because Azure Functions are event driven, so they are triggered by something, and it could be, like I mentioned before, it could be that a message is put on a queue, it could be a blob file that's created, or it could be that an URL is invoked. So the trigger always needs to be there. But then there are two optional things. One is you can have an optional input, and that input can be completely unrelated to the trigger. So for instance, when we have an HTTP triggered function, we can configure an input that is related to a blob, for instance. So we can specify something in the query string of our HTTP triggered function that contains the name of the blob. So when the code is executed, the input will make sure that we read the blob file whenever we invoke this code. We can also configure the output easily, and again, the output is also unrelated to the trigger and unrelated to the input. So in case we want to put something on a message queue as a result, we can configure a so-called message queue output binding. So our HTTP trigger could read something from a blob as an input, and we can put something on a message queue as an output. So these things are all configurable using attributes. We won't be using the input and output bindings in this webinar much, but I'll link to some additional resources later where you can use a lot of storage related bindings to experiment with this. But this configuration of input and output bindings makes it really flexible and really easy to use Azure Functions, but also combine it with lots of other services on Azure, just writing just a tiny bit of code. So when you create your function locally, just on your local machine, you need to deploy it. But you don't deploy an individual function, you are deploying a function app. So you have a function application, and that application, that function app, can contain multiple functions. When you create initially, that function app will be empty, so it doesn't contain any functions. Of course, it's useless then. But you can deploy many different functions inside this function app. So which is nice because you can group several related functions into one function app and deploy that as a unit. On the function app level, you also have application settings. So for instance, if you need to have connection strings there to databases, or if you need to put API keys in there, you can put them in your application settings, and then your functions can use those settings. All right, so that was the theoretical part. Let's now actually build something. So if you follow this link, bit.ly/az-func-uni, you'll end up at this URL, Azure Functions University. So let me go there. Where are we? Here. And I also need this. So you end up here in this repo, Azure Functions University. And this contains a lot of practices, lots of lessons, how to create Azure Functions in different languages actually. We'll focus on .NET 6 in this webinar. So as I scroll down, we have several languages. So we have .NET Core, .NET 6, TypeScript, PowerShell, and even PowerShell in the portal, I believe. Oh, Python as well. So this table and list is continuously growing. Also, if you want to help out creating lessons, you are more than welcome to do so. So in this webinar, we'll be focusing on .NET 6 and creating HTTP triggered functions. So that's this lesson. So I'm clicking on this check mark. So this is the lesson we are going to follow. I don't think I'll run through it completely because there are quite some exercises and I want to keep it well within the hour. But let's just do it at least until number 3 or 4. We do need some prerequisites. So let's look at that first. By clicking on this link. So since we're working with .NET 6, we need to have the .NET 6 SDK, so make sure you have that installed. I'll be using VS Code to create everything, so if you really want to follow this hands-on lesson, I also suggest you use VS Code. And we'll be using the Azure Functions extension for VS Code, which makes it really easy to create new functions and also deploy them to the cloud. When you create this extension, you will also install something that's called the Azure Functions Core Tools, and that allows you to run Azure Functions locally on your machine. So it's actually using the same runtime as in the cloud, but the Azure Functions Core Tools is just running in a local development mode, which is great for local debugging and testing. So we'll be using this a lot also in this webinar. The rest is this final one. Yeah, you will need a REST client because we will invoke an HTTP triggered function. So I'll be using the REST client within VS Code, but if you use the Postman, you can also use Postman. We don't need the rest of the prerequisites for this lesson. All right, let's go back. So I'll start with creating a function app now in VS Code. So I have VS Code here open to the right. I have my side panel. I have it on a different side maybe than you're used to. It's just my preference. I've created a folder called ESPC and I've opened that, and that's the only thing I've done so far. So let's create a function app now. If you've installed this Azure Functions, let me show it you. If you've installed this Azure Functions extension, that's this one. When you run the open command palette, Ctrl-Shift-P, there are a lot of Azure Functions related actions you can do. You can see them all here. You can do a lot of different things, but right now we're focusing on creating a new project. So click this Create New Project one. It will ask, okay, where do you want me to create this new project? Well, you can create it in this folder I have open here. So I'm just clicking that. Then it's asking, okay, which language do you want to use? Because Azure Functions supports many different languages. In this case, we're choosing C#. Then it's asking me to select a .NET runtime because there are different versions of Azure Functions, and each version of Azure Functions also allows you to create .NET functions in different runtimes. So these are older ones. This is .NET Core 3.1 and .NET 5, but I want to create something in .NET 6, which means I need to switch the Azure Functions version to the latest one. Maybe for you it's already default on Azure Functions v4, but mine is somehow stuck on v3, so I always have to select Azure Functions v4, so that's the latest one. And then you see these options, which are the latest versions of .NET to use. So for .NET 6, there are actually two flavors. You can use this one, .NET 6 LTS. So that's the long-term servers, or this is the in-process one, or you can use the isolated one. So there are at the moment two different ways to use .NET 6 versions with Azure Functions. And this first one, which we're not going to use, this will run your code inside the same process as Azure Functions is running. And that was the way it always was with Azure Functions, specifically for C# and .NET 6. But all the other languages used more like an isolated process. So they had an isolation between the Azure Functions runtime and their own code, their own worker code. So that's called isolated. So isolated is, I think, really the future of how things should be running, because it allows you to have a bit more control about your environment. So I'm choosing .NET 6 isolated. The final thing, or I think one of the final things I have to select, is what kind of template do I want for my Azure function. And for this webinar, we'll only be focusing on HTTP triggered functions. So that's what I'm going to choose. And then we need a name for our function. So I'm going to use the hello world HTTP trigger name. And the last thing it needs is a namespace. And yeah, if you're not familiar with C#, a namespace is more like a grouping of code, which is completely up to you how you define that grouping. In this case, I'm using azfuncuni.http. Now, this is the final step. So the access rights determine how your function can be executed. So if you set it to anonymous, which I don't recommend, then if you deploy it, anyone in the world can access your function. I think by default it's set to function, and I think that's good, because if you deploy to the cloud, then you need a specific function code in order to invoke your function. So that will be the safest thing to do. If you set it to admin, then you need this special admin key. So this is more like for to access internal workings of your Azure function. So you usually don't really need this. So I say keep it on function. When you're running locally, which we will be doing most of the time, you don't need to use this function code. So this is only important when you're deploying it to Azure. All right, so in the bottom right, we see now it's creating our project and it's creating a new HTTP trigger. And we now see our function here. So let's briefly go through this class file and also look what else this template has created for us. So we're now in this class, the hello world HTTP trigger class. So it's a regular .NET class file. It has a constructor where some iLogger factory is injected. So if you want to log some things, either for debugging or other purposes, you can use this _logger. And this is actually our function. So let me hide this a bit. So the function attribute is used to identify a function, and identification of function is done by name. So in this case, it's the same name as the class. Usually I don't like these strings. So what I usually do is I use name of, and then I use the class name. So whenever you rename your class, this is then renamed as well. This means, though, that you should limit yourself to only create one function per class. Sometimes I see examples of people having multiple functions within a class. That's also fine, but then you can't use the class name as the identifier of the function anymore. All right, so what does this function do? Well, I've mentioned the trigger. So in this case, because every function needs a trigger, in this case it's an HTTP trigger, and an HTTP trigger always have certain components in there. So in this case, it talks about the authorization level, which we've selected earlier. It's set to function. So when we deploy this to the cloud, it will require a function code to be able to be executed. And then there's a list of different HTTP methods which you can use to invoke this function. So we can either invoke this with a GET request, or we can invoke this function with a POST request. Then the input of the function is of type HTTP request data. So we can use this rec variable in our function, as is used here. And the output is an HTTP response data type. So if you used maybe .NET Core, Azure Functions with this, then you see that this input and output types are completely different. So it's good to familiarize yourself with these new input and output types. But what this function is doing, it's using the logger to log some information. So we'll be seeing that in our terminal output as soon as we run this function. And then it doesn't do much. The only thing it does is it will create a response, and it will include 200 OK output status. It will add a header to the response, and it will just write a string to the output, and then it will return it. So let's see how this runs. Let's see if this is working. So if you've installed VS Code and installed the Azure Functions extension from VS Code, you'll be able to run this right here in VS Code. So let me press F5 right now. So now it will build the project, and so that's what it's doing now. It starts building, and then it will also start up the local Azure Functions runtime, so we can actually trigger this function. So here we see the Azure Function core tools and the version. So this is the local development instance, and here we see that our hello world trigger is accessible at this URL. All right, and we see some default output here. So I'm going to copy this URL because we can trigger this now. We can call this now, and I'll be using the REST client within VS Code, and that allows me to create this file. I'm calling it local.http, and I'll be writing get, and then I'll be pasting in the URL. And because I have this REST client installed, there's now this label, this button here called send request. And so when I click that, it will execute a GET request to this endpoint. And when I do that, we will see the output here on the right, but we'll also see some stuff in the terminal below. So let's do this. All right, well, we see the output, it's 200 OK, and we see the text in the body as well. Welcome to Azure Functions. But we also see some stuff here, right? So we see some things are being logged. So we see that the function is executing. Then we see the logging statement from the function, and then we see that the function is executed. So it's useful to know that there is some output going on by default. You can even make it more verbose if you want. So in case the output of your function is not working, or maybe you can't even call it, definitely have a look at this terminal output. So it usually gives you a bit of more indication what's going on. Okay, I'm stopping the debugger. All right. So we've seen the class file now, but there are some additional files which we haven't talked about yet. So for .NET 6 functions, for the isolated ones, we also have this program.cs file. Let me move it in here. Get rid of this. So this program.cs file, and that will create a new host, and that's the worker process, and that will actually run your Azure Functions. So if you want to do a dependency injection, or you want to override some defaults that Azure is using, you can configure that in this program.cs, much like as you're doing with ASP.NET program. So this is the CS project file itself. So the target framework is mentioned, the Azure Functions version is mentioned, and it will list some of the package references that we're using. So in this case, we are using the isolated model, which requires us to use the Azure Functions.worker packages. And since we are working with an HTTP trigger, it's using the .extensions.htp package. So if you're using different triggers or different bindings, you'll need to install different NuGet packages. For instance, which have different names for queue storage or blob storage or service bus. Another important part is this host JSON. So this is also created by default, and you can use this to override all kinds of behavior and configuration of your Azure function. So in this case, only the schema version is mentioned and some application insights configuration, but you can override lots of other things related to Azure Functions. So you can even control a bit from how much is scaling out, how much parallel processing it's doing in case you're using queues or service buses. So there's a lot of stuff you can configure here, but this is quite well documented in the Azure Docs. The final thing I want to show you is the local settings JSON. As you can see, it's a bit grayed out, so it means it's excluded from Git. But it's a very important file because that also contains some configuration for your function. So the Azure Web Job storage is now empty, but your Azure function depends on a storage account once you deploy it. Because when your function scales back to 0, so no instances are running your code, it means your code does need to be stored somewhere. So it's using a storage account to actually store the zip file that contains your code. So that's an important variable. You don't need it when you're running locally, but it will be populated automatically when you deploy it to Azure. Another very important setting is the functions worker runtime, because that will determine which runtime is used to run your function. So in this case, it's .NET isolated. If you're running the in-process.NET, then it's just simply .NET, and otherwise it's just depending on the language, right? So it's JavaScript for the Node versions, and it's Python for the Python functions and so on. If you're using connection strings or API keys or whatever, this would be the place to put them in when you're developing locally. All right, so I've gone through all the files. We have made it run. We only did a GET request, but trust me, it also works with a POST request. But let's change the template now. Let's go back to my file. So let's change the template so it only works for GET requests, and we will also return a value based on a query string called name. So instead of the hello world, you can actually provide your own name and then invoke that. So what we need to do then is, right now, this function can be triggered with both a GET and a POST. So let's remove this POST. So we only have a GET now. And the other thing we need to do is, since we now need to access the query string, we need to use another namespace, which is the system web namespace, because that will contain the HTTP utility we can use to parse the query string. So I'm putting in this, and I'm copying this part. There we go here. And I'm putting that right in here. So what this will do, it will use the HTTP utility class that's part of the system web, and it will parse the query string. So this is the request, HTTP request data. So we access the URL property, which has a query property, and that will be parsed. We get back a collection of query string key value pairs, and we want to extract the name, the value for the name key. So this will hold the name. So the final thing is, of course, that we actually want to give back the name instead of this default welcome to Azure Functions. So now let's replace this with hello, then name. All right. So this is what the function should look like now. So let's actually build and run this. So now it's building the solution again. And now I need to go back to my test file here. Okay, so the URL is the same, but now it expects like a name key and a value. So PC. Okay, so let's call this, and it gets back a 200 OK and hello ESPC. So that works. All right, it's great. But let's do something else and actually not provide this name string at all, and let's send a request then. So now it's a bit weird because we still get back a 200 OK, but we didn't get a response back with the name, right? Because we didn't provide the name. But the function says, oh, I'm all fine, I'm all okay. So this is not a good practice, right? Because if you miss some input, you should really make sure that you give that feedback to whoever is calling this endpoint. So now let's go to the next exercise and add a bad request response. So in case we are missing some information, we don't give back a 200 OK, but we give back a bad request. All right, let's close this. I already changed the function to the name of, so that's done now. But now we are going to check if the name is actually not empty. So I'm just going to copy paste this code again. Headers here. Now I need some formatting. Oh, I think I pasted something too much right now. Let me see. Yeah, I think it's fine. So the only thing we added is we add an if statement that checks the name, the variable. If it is null or empty, the state code of the response will be set to bad request. And then we also provide some meaningful output that please provide a name for the name query string parameter. If the name is not null or empty, then the HTTP state code will be okay, and then we'll report back the hello and the name. All right, so now let's run this again. Okay, so the endpoint is available again locally. Let's use my test file again. So first, let's try it with a name. Name is C. So let's execute that, and then we get back a 200 OK and hello ESPC. So that's correct. But now, for instance, we can do it like this. So we do include the key, but not the value, and then we get back a bad request. So that, and also if we remove this completely, then again, we get back a bad request and some useful information that we need to provide the name query string parameter. And so this is a good practice to do. Always make sure you validate your inputs and give a appropriate response back to whoever's calling your endpoint. All right. Let's see. Yeah, let's do this exercise, and after this exercise, let's do the deployment part, because I think there is still time for that. All right, so we were now dealing with GET requests, but now let's deal with a POST request. And let's see, put something in the body. So if you want to allow POST request again, then we should put this back. So our function works with both GET and POSTs. And instead of checking this query string right away, let's make sure that the query string is only checked when we do a GET request, and we will use the request body when we do a POST request. And so this part of the code should not be done for both GETs and POST. This should only be done for a GET. So let's change this. All right. One more. Right, we see some red squigglies now here. Let me first explain the code. So we create a new variable for the name, and we set it to a default value, which is in this case null. That's what we're complaining about here. Then we are checking the method of the request. So in this case, we check from, is this a GET method? If so, we'll do the same query string parsing as we did before. If it's not a GET, it can only be a POST, because those are the only two methods we allow. So then we will be reading the body of the request as a string and use that for the name. So now this is a red squiggly, so that means there's a problem now. And this is an asynchronous function, but our function is not asynchronous. So we need to change our function a bit to make sure that we can actually build this. So it means we need to use the async keyword here, and async functions always have a task as an output. In this case, it's the task of the output it was before. So now it's working. I'm ignoring the possible null values here for a moment, but at least it's building now. So this is all done with. Right, string async, yeah, this is all fine. All right, so now it's time to test this. So let's run this function again. And we can now test it by making a GET call and making a POST call. So now the function has been built, and now it's the local runtime is up and running. So let's get back to the test file, which is this one. So I'll just copy it a few times. So this will be the GET with the name. And we'll do another one, and this will be a POST. Which will be the same URL, but we won't provide a name. But here we do it, yes, you see, as the body. Oh, we need to content type as well. Content type is text plain. All right, so let's first do the first one. So hopefully we have still the same functionality. So this is using the name query string parameter. So let's do that. And we get back a 200K, and it says hello ESPC. Perfect. All right. Now let's do the bottom one, which is using a POST and then using this value from the body. Let's do this. Yeah, and get back 200K. Hello ESPC in body. So this is all working. But let's now also try a POST without providing any value, because that should result in a bad request again. And indeed, now we get a bad request. So now we have a function that works with both gets and posts. And based on the get, we will get it from the query string, and based on the post, we will use the body. Great. So I won't go over the next exercise. It's all available for you to do it in your own time. I definitely recommend to do it. I think it's quite nice because the next one will be about JSON data, and that's very common to be used. So definitely recommend doing this. And there's also a bit of more advanced stuff that you actually can change the route of your endpoint and use that with some more parameters. Let's now focus on actually deploying this function to the cloud. So for this, you need an Azure subscription. So yeah, if you don't have that, you can get a subscription for free. So you can sign up for that. There is also a dedicated deployment lesson for this for .NET 6, also in Azure Functions University. So that's this page. Again, I won't go through all of the exercises because there are a lot of different ways to deploy your functions to the cloud. We are only doing exercise 2 and deploy it using VS Code. But first, let's talk a bit about the resources. I already showed it a bit when I showed the slides, but you don't have a single function running in Azure. You have a function app running in Azure, but that function app that doesn't run. You can't simply deploy a function app on its own. All Azure services run in a thing called resource groups, which is just a logical grouping of services that belong together. So when you deploy or create an Azure Functions instance in the cloud, you're actually creating a resource group first. So that's the outer box. And in that resource group, an app service plan will be created. So this is all done for you. You don't have to worry about this. And the app service plan determines the size of the virtual machines that are actually running your function apps. So when you're running completely in serverless mode, you don't have any control over the size. It's just one size, I think, with just 2 cores and 1 gig of internal memory. So it's very small, lightweight machines. There are other more premium plans where you do have a bit more control. If you want more CPUs or you want more memory, you actually have control over this app service plan. So it creates a resource group, it creates an app service plan, then it will create a storage account instance as well, because that storage account is used to deploy your zip file that we created when we deploy our code. And your function app will actually be referring to the storage account where that zip file is located, and it will be executed whenever a new instance is needed of your function app. So it will get the zip and it will deploy it to the function app. So there are actually quite some different Azure components involved when you deploy an Azure function to the cloud. But the good thing is, all of the tooling, especially when you do it from VS Code, takes care of it for you. So it only looks like you're deploying one thing, but several things are being deployed under the hood. So let's do the VS Code one because it's quite a straightforward one. The images these days look a bit different than in the documentation because they recently changed the way the Azure extensions look here. So if we go to my Azure extension here, it used to be that Azure Functions was a dedicated high-level thing here, but it's not anymore. Everything can be found now under resources, and that starts with your Azure subscription. I have 2 subscriptions, and under that subscription, you then have the individual resources. So here are the function apps I have running already. So what we're going to do is we want to create a new function app instance. So that's the thing what we do now. So if I right click this function app header, I have 2 options, well 3 actually. I can refresh, or I can create a function app in Azure, or I can do it the advanced way. And I'm not doing the advanced way because I don't need a lot of control over namings of specific services. Let's do the basic one. So click this. So it needs 3 pieces of information. We need a globally unique name for the new function app. So I'm calling it ESPC function app. I'm not sure if that's actually unique, but let's see. We need a runtime stack. Well, it's already detected from my code. I'm using .NET 6, and that's using Azure Functions version 4, so that's fine. I do need to make one small adjustment later though, because it's now assuming that I'm using the .NET 6 in process mode, but I'm actually using the isolated mode. But we'll see that very soon. And we need to select a location where everything will be created. And the nearest location for me is West Europe, so I'm choosing that. All right, so right now it's doing a lot of different things. So here you can see it's creating the app service plan for us. And it's using our ESPC FA name as part of the name of this app service plan, and then appending it with some numbers. So now you see it's creating a storage account as well. And the first one, it went very quickly. It was the resource group. And one of the things it will also create is an instance of application insights. So if you're not familiar with Azure, application insights is a very useful service about where you can visualize all of your logging and monitoring that you're doing. So in this case, we are logging something here right here. So that information, when you execute your function in the cloud, this information can be found in application insight. So now it's creating the new function app, and that's then the last part of this whole wizard. I already have Azure open here, so when it'll also be shown here, by the way, once it's done. This is one test instance I created earlier, but let's wait a bit longer. If I look in Azure here, okay, it's now here. It's not yet in this list, so let's refresh it here as well. I don't see it in this list. No, that's fine. Okay, let's just show it in here. So here we see our instance, ESPC FA. So if we expand that instance, so I can get rid of this, we have we can visualize some we can drill down deeper into some stuff. So we can look into the functions, but that will be empty because we only created an empty instance of a function app. So this will be empty. It will look around for stuff, but it won't find anything. As I mentioned before, a function app has application settings. So these can be seen here. And I am actually going to change one of the application settings because we were creating a .NET isolated function in here, which is a bit different than a regular .NET in process one. So here is our functions worker runtime value, and by default all of these values are hidden, so you can click it to view it. And that functions worker runtime is set to .NET, but our local version is set to .NET isolated. So what I'm going to do now is I'm going to copy this functions worker runtime value, and I'm going to paste it in this one. So when you right click one of these settings, you can edit them, and then you can paste in the new version. So if you don't do this and you try to deploy your code to this function app, it will fail because the functions worker runtimes don't match. This still needs to be changed in this VS Code extension. So I think it's a bug. I will make sure that we get back to the team. So there are some other default application settings. You don't really need to be aware of it, but for instance, one of them is the Azure Web Job Storage. So it contains a connection string to the storage account that Azure Functions is using. So here you can see it's actually used. And since we are using application insights as well for logging and monitoring, that needs an instrumentation key, and also that is automatically populated for you. All right, so now we have an empty function app in the cloud, but now it's time to deploy our code to the cloud as well, so we can actually execute our function in the cloud. So let's do that. So if you right click this function app, you can say deploy to function app. That's what we want to do. It will then give a warning, which is very small. It mentions, are you sure you want to deploy ESPC FA? This will override any previous deployment and can it be undone? Yes, we want to deploy that function instance because it's empty anyway, so I'm not even sure why this is a problem, but yes, please deploy. So now it's building the solution again, and we can monitor here what's going on. So it will build the solution and it will zip it and it will deploy it. Yeah, so now it's deploying. Let me also refresh it here to see if it's, I hear it's also available now. All right, it's still deploying to our cloud instance. And once it's there, I can copy the URL then of the cloud instance and we can execute that URL so we can actually prove it's running correctly in the cloud. Still deploying. So if you use the Azure portal, you have a lot of things to look at here. Okay, deployment is completed. If you look at your function app in the portal, there's this overview tab where you can see the name and if it's running or not and where it is deployed and what is the subscription ID and so on. You also see the base URL of the function app and you can see which service plan is used. But also here you can have a look at your functions. So here we can see it's the hello world HTTP trigger, and you can click on that and you can actually inspect some stuff in here. What the nice thing is, we can either trigger it here from VS Code now, but we can also trigger it from the browser. So if you go, for instance, for oh no, it was this one, this code and test one. You can actually test this trigger right here in the browser. If you click this test and run, it doesn't show anything here. But I'm just going to do it from VS Code. So now this function lists our HTTP trigger function. So if I right-click this, I can copy the function URL. I can go back to my REST client file and I can paste it in here. You see this very long code, right? So in the beginning, we mentioned that we need to set the access rights and that's set to function. So since we're now deployed our function to the cloud, we need this function code because if we don't provide this, we don't have the proper access rights to execute the function. So if we do a, well, for instance, if we do a post now, and if we use the same content type, do this, and it's now running in Azure. So if we execute this, we'll be executing our deployed function. So let's trigger this, and we get back 200 hello running in Azure. And yeah, as you can see, it went really fast. It was almost faster than executing it locally. So our function is up and running, and it's working fine. So that's nice to see. All right, that was the hands-on part for now. We've built it in VS Code using the Azure Functions VS Code extension, which really makes it very easy to scaffold all your projects. We've shipped it to the cloud also using the Azure Functions VS Code extension. If you want to know more, you can definitely look into Azure Functions University, which is great and contains a lot of things. I've also created a dedicated repo if you're interested mostly in different storage solutions, and it uses table storage and message queues and blob storage and also durable entities. And so these are a couple of more advanced patterns. So if you want to learn more about that, have a look at this. And if you still want to learn a bit more and want to see a real life solution, I could definitely recommend you to go to this URL. It's quest.ably.dev. It's a kind of a mini game that's built with the backend completely serverless. So it's using Azure Functions and it's using durable functions, but it's also doing some real-time communication with the browser. So you can actually play this AD&D game by choosing one of these fighters and then defeating a monster. So this is really a proper end-to-end example of how you can combine a serverless backend with a nice, in this case, a Vue front end. The link to GitHub is also there, so there you can see the complete implementation. If you need any more information, feel free to reach out to me on Twitter. I've also got a YouTube video about Azure Functions University. Contains lots of information about Azure Functions and durable functions. And if you want to have a look at my GitHub repo, there's lots of samples there as well. If there are any questions, now would be a great time.
That's great. Thanks a million, Marc. It was a great presentation. As Marc said, it's time for questions. If you have any, go ahead and type them into the questions window. I do have a few in that we can get started with. Marc, what are other serverless options? What other serverless options are there within Azure?
Yeah, there are quite some, right? So if you look at serverless compute within Azure and next to Azure Functions, which are more focused for the developer audience, there's also logic apps, and that has quite a nice user interface, which is more like a click and drag UI, and it's great for integrating with hundreds of other different services. So it contains integrations for whatever other third-party service you can think of. There is a connector for that in logic apps. And Logic Apps is actually also running on the same Azure Functions runtime. So even if you use Logic Apps, which is, let's say, a more maybe business user-friendly version, you're actually using the same technology, which is running both. So that's a nice one. Another one is, for instance, Power Apps can also be considered serverless. So that's really like a low-code solution, which is nice. If you look at more storage kind of solutions, there is Azure Cosmos DB. So that started out like a not serverless, so you pay like a fixed fee a month, but there's also like a serverless option now, so you pay really for what you're using and how many queries you're doing. Also, SQL Server is also now a serverless option. And many of the, let's say, cognitive services, right? So if you do like image processing or voice processing or stuff like that, those are also available like serverless, because you only pay for when you invoke those services and not for anything else. So there's quite a lot available on Azure.
That's great, thank you. One more question has come in. Is any of this used in real life?
Yes, definitely. Yeah. And so before I joined Ably, I did a lot of consulting where I really did hands-on development in product teams. So actually a lot of banks and insurance firms in the Netherlands, which I've helped, are using really Azure Functions and also mostly durable functions, which allows you to create all kinds of business workflows in code. So yeah, it's more than just like the new shiny thing. It's actually being used in production quite a lot.
Great, thanks a million, Marc. That's the end of the questions. Marc, thanks so much for taking the time. We really appreciate it.
You're welcome. Yeah, it was nice.
It was great, thank you. That marks the end of today's webinar, folks. Thanks very much for joining us. The webinar will be available in our resource center later on, the recording, and I'll let you know when it's available. Thanks again and goodbye. Thanks, Marc. Bye.